These are the video notes for section 2.3. Our essential question is, how do I use reasoning to reach conclusions? So we start with the idea of deductive reasoning, which is a process of reasoning logically from given facts to a conclusion. We will often use the idea of the law of detachment, which means that if P then Q is true, and you are given P, you can conclude that Q is true. We will often simplify things just by using the letters P and Q. All right, so here we're saying if P then Q is true, and you are given P, so we are given P, then we can conclude that Q is true. All right, so let's try this out. So this first one says, if Maria saves at least $1,200, that is my P statement, all right, that's P. Then she will buy a car, that's my Q. Maria saves $1,400. Oh, so that's P, she saved at least $1,200. What can you conclude? I can conclude Q, she will buy a car. All right, given the conditional, if a triangle has three congruent sides, then the triangle has three congruent angles. So with that being said, if triangle ABC has sides of 5 inches, 5 inches, and 5 inches, all right, so that's my Q. It fits perfectly with three congruent sides. That's Q. What can you conclude? I can conclude the P. The triangle has three congruent angles. All right. Here are two true statements. If angles A and B are a linear pair, then measure of angle A plus measure of angle B equals 180 degrees. Here it says that the measure of angle 1 equals 90 and the measure of angle 2 is 90 degrees. All right, well, we don't know if they're a linear pair because angle 1 and angle 2 may not be adjacent. So I don't know anything about that. So I can't conclude anything. I don't know they're a linear pair. I just know their measures. So we can't conclude anything in that case. Law of contrapositive. If P then Q is true, and you're given not Q, you can conclude not P. So this is like the opposite. We use these little symbols here called tildes. That's what this is, to negate, to mean the opposite. So I'm saying if the opposite of Q, so the opposite of this part is true, then we can conclude the opposite of this part. All right, so it's a little different that way. So if I go to school, then I take math. So that's P, then Q. Now I'm saying I don't take math, not Q. So what does that mean? Not P. I don't go to school. If you are not in Chicago, then you can't be on the L. Sally is on the L. So this is the P, this is the Q. Sally is on the L, which contradicts the Q. That is not Q. So what does that mean? Not P. That means that she is in Chicago, because the original statement says she's not in Chicago. So this negates that. She is now in Chicago. If you are not in Chicago, then you can't be on the L. Bill is in Chicago. So this is P, then Q. Bill is in Chicago. Well, that's neither P nor is it Q, so I can't conclude either because it doesn't match up with either of those. All right, law of syllogism. If P then Q is true, and if Q then R is true, we can conclude that if P then R. So here's the idea. We start with some statement implying another one. And where we finished picks up on the next one. That leads us to a new bit. All right? If that's the case, then I can just basically ignore this middle bit to be left with the end. All right? So we'll just bring together the first bit and the last bit. All right? So let's give this a shot. If Sue wakes up early, then she'll go hiking. All right, so if Sue wakes up early, then she will go hiking. If Sue goes hiking, then she will go out for breakfast. All right, so it says, what can we conclude? Well, we just look at the first bit. If Sue wakes up early, oh, sorry, new tools. If Sue wakes up early, then she'll go out for breakfast. All right, so we basically ignore that middle part here. That just goes away. All right, connects the first and the last part. If Miranda has a test tomorrow, then she'll go to bed early. So if Miranda has a test tomorrow, then she'll go to bed early. If Miranda goes to bed early, then she'll wake up on time. All right, so we can basically cancel out this middle part that is the same. That means that by the law of syllogism, if Miranda has a test tomorrow, then she will wake up on time. We can actually get super fancy with that. If Jolene goes outside, then she'll go for a walk. All right, so we've got, if Jolene goes outside, then she'll go for a walk. If Jolene goes for a walk, she will go through the forest. If she goes through the forest, then she will see a squirrel. All right. By law of syllogism, what can we conclude? All right, so we basically say this part and this part get rid of each other, and then this part and this part get rid of each other. So we are left with, if Jolene goes outside, then she will see a squirrel. Okay, there we are. Have fun.